Hi, I'm Theodore Boehm, a senior at Penn State Behrend, working on the Robotic Explorer for Hypothesized Surfaces team with Aidan Domencic, Isabella Pilyih, and Pietrzyk. Have you ever wondered what is at the core of the Earth? The core is impossible to directly study due to immense temperatures and pressures. It's the same story for other planets, but that's where our project comes in. The Psyche asteroid is hypothesized to be the remaining core of a planetesimal. The problem statement we devised is design a rover's locomotion system that can traverse the hypothesized surface of the Psyche asteroid. There are several major challenges that come with the project. Near-zero microgravity, the lack of physical evidence of what the surface actually looks like in the harsh conditions of space.
In order to select an effective design, an extensive concept selection process was performed to cover all the possibilities. We modeled 5 different concepts and graded them based on performance on the surfaces, simplicity, and manufacturability. The concept that we decided to move forward with was the tank concept shown below. Next, we found that there was room for improvement, so a flipper was added to the bottom of the rover so that it can vault itself to perform better on the crack and shelf surfaces that may be found on the asteroid. To further develop the rover, 3 concepts of the wheels were made, and the one selected was a rectangular-shaped design shown below in the red box. Finally, 4 concepts were generated for the gear and tooth, and the one on the far left shown in the red box is the one that we selected. Now, with all the components of the rover selected, here is the final assembly of all the parts. Next, the technical analysis began with material selection. The criteria for the material include: must be an aerospace application, it must have a high fatigue strength at 100,000 cycles, it must have a low thermal expansion coefficient, must be lightweight, have high strength, and have low cost. And with all these considerations, the material that was selected was aluminum 7075.
Okay, now we're getting a little bit into our technical analysis here. So first we're going to look at static loading, which is basically all the forces acting on the components of the rover from the weight of the rover on the surface. Then we'll get into our impact analysis. So this is basically just the rover landing onto the surface of Psyche. And then after that, we will look at fatigue analysis, which is based off a 1-month mission on the asteroid. And then we will look at thermal stress throughout the rover. Here is a video of one of our impact simulations.
To produce a prototype for a proof of concept, our design was 3D printed. For lab testing, we obtained materials to create our 6 hypothesized surfaces based on our specs and the 1/6 scale. The videos will show that the design was able to successfully traverse across these surfaces. The smooth metallic surface, which determined the optimal speed. The regolith, which was successful, not getting sand in the gears. The rocky surface. Crater slopes that maxed out at 30 degrees. The surface cracks up until 5 inches. And the shelves up until 2 inches. Thank you for watching.